The Association of American Railroads Operation Maintenance Department Electrical Section Engineering Mechanical Division Manual Standards Recommended Practice Section 4. Motors and controls, table contents, motor part 1, motor controls, motor general, motor classification characteristics, motor data, and motor size of railroad machine tools. Chapter 2 controls, motor control general, and motor general control apparatus is part 2, chapter 2. Chapter 1 General. Motors General. The factors to be considered with selecting the motors available to power supports the electrical direct current and voltage phase and the frequency of the regulation line drops, surrounding conditions, ambient temperature, moisture, hazardous conditions, dust, corrosive vapors, altitude, starting condition, torque required low, medium, high, the rate of acceleration desired, reducing the voltage across the line, starting number at the start of the per hour, running the condition, speed, constant, variable, adjustable, high, medium, lows, multiple speed, reversing, non-reversing, continuous, and intermediately duty. Special requirements, local power and company requirements, municipal, state, and federal requirements, mechanical features, vertical, horizontal mounting, ball raper, ball roller sleeve wearing, and a type of lubrication standard, special shaft, slide basing, pulling, pinion, and brake, and auxiliaries, gear types of motors, other special construction, vibration proof. Chapter 1 Motors and Operation, Motors and Controls, Chapter 1, Part 2, Motor Classification Characteristics. Direct current motors to the characteristic of the shunt motor fairly constant, a speed for all reasonable values loaded. The general applications where they have starting requirements that are moderate and constant speed is required in Table 1, Figure 1. Series of motors, they have only excitation windows that are connected with the series of the armature so that the current flows through the field as well as the armature. The characteristics of the series motors are speed change with every condition of the charge and loaded, the high speed of the light load with the low speed of the heavy load, the speed of the dangerously high at no load. The series motors must always be connected rigidly to its load. Since the torque is high at low speed, the motor is particularly adapted to the work requiring frequent starting in Table 1, Figure 2. Compound motors, they have both shunt and series winding with each of the pole wounded two winding settings and called cumulative compound, the opposite differential compound. Each other protection magnetism, the cumulative of the compound motor has been good starting. The qualities in the series motor avoid with the danger succeeded with the speed of light loads. The differential compound motor is unstable to change the loading and the seldom used. The Table 1, Figure 3. Alternating current motors, single phase and square cage indicated motors, the most popular and single phase varieties, especially the fractional house power range. The advantage of the split phase motor includes the low cost, fairly good to the speed loaded and characteristics, medium to start torque. Table 1 through Figure 4 and Table 1 and Figure 4. Capacitor standard induction motor. The substantial increase of the starting of the torque can be realized placing in capacity with a series while the standing of the wiring and the resultant phase then can be provided with the starting the torque 3.5 times the full loaded torque of the single phase motor, but the capacity may be selected for the optimum starting characteristics since it is disconnected when the motor approaches operating speed. Table 1 and Figure 5. Capacitor running and induction motors, similar to above the type of except the capacitor auxiliary winding and the permanently connected in the circuit. This motor is usually used most efficiently where the load is relatively light and constant. Table 1 and Figure 6. Capacitor starts. Capacitor run motor is a combination of the preceding the capacitor motor. Figure 5 and 6. Construction central figure switch disconnected starting capacitor but does not affect the separate running capacitor. Table 1, Figure 7. A repulsion motor, if it insisted, instead of connecting the field armature to the series, the supply of the voltage is connected with directly across the field with the armature brush. If the short-circuited simple repulsion motor is obtained with the brush shifted into the line with the stator winding of the motor to become the short-circuited transformer drawing it accepts the current with producing zero torque. As the brushes are shifted away for this position called the live neutral flux and produced into the cross axis, the torque is developed in the same direction as the shift. The force shift the brush results in a gradually decreasing current with the torque that passes through the maximum angle of 15 to 25 degrees, finally falls neutral 90 degrees as that introduce the current the armature to current zero. The typical torque is also zero. The armature speed of any setting of the brush is the speed voltage due to the armature conductors connecting the field flux opposite with the transformer voltage due to the compensating flux inducing the armature current is also decreased in line with the gradual increase of the flux along with the brush axis as synchronizing the speed of fluxes into the two axles are equal and given a proper rotation magnetic field. The propulsion motor has been in computation with a series of motor speeds that synchronizing the poor communication at very high speeds, owing the great value of the currents inducing the short-circuited coils under the lower ladder conditions. These include the currents and provided with the brake effort of the serve the limited to high load, no load speed. The propulsion motor has the two important advantages over the series of motor with the small power industrial application of the amateur being isolated with the line being designed with any convenient low voltage where little no brush yoke of the insulation is needed. Also, pure rotation magnetic field produced the synchronized speed gives an exact neutralization of the voltage induced to the short-circuited goals, therefore giving a good commutation at the speed table 1 figure 10 result propulsion starting induction running motor. The desirable combination of the high starting torque and low starting current with the propulsion motor with the constant speed characteristics. The inducing motor has been led through numerous designs. Automatic shift from the repulsion to the induction characteristics is about 2/3 of the synchronizing speed. The most usually type of it has been the form of the centrifugal mechanism that short circuits the communicator bars at the predetermined speed. The high speed, therefore, the armature winding effectively becomes a simple squirrel cage. The motor has normal single-phase induction motor characteristics. Many such of the material motors combined with the brush link mechanisms of the short-circuiting device so that they brush noise and were absent during the normal loading operation. Table 1, Figure 8. Propulsion induction motors. Instead of employing a central fugal switch, some of the designers provided the in-body low-resistant squirrel cage winding of the armature of the propulsion motor. The high reactance of the squirrel cage causes it to draw only the small emission current of the starting, and so that the starting characteristics are only slightly inferior with the propulsion motor. As the motor accelerates, produces the rotor frequency, enables more and more of the current flow to the low-resistant squirrel cage at the rate of the speed of the induction motor characteristic predominates. The no-load speed is slightly above synchronism, and no-load current flows lows. This is a little lighter than at the partial loads owing the induction generator action to the squirrel cage and the opposite of the propulsion motor torque. The squirrel cage has an also strong power factor, correcting influence and giving these motors power 10 factors. Power factors 10% more, great better than other propulsion motor types. Figure table 1, figure 9. Universal series of motors consisting of field winding and the series of the commutator rotor may be used in either alternating directing current. No loader speed frequency at run as high as at 10,000 to 12,000 RPMs. Reasonably good speed control may be attained by varying the input voltage. Table 1 in figure 14. Polyphase squirrel cage motors, mostly wide for the industrial application of the rotor design, can be varied to provide different starting and the running characteristics. Table 1 in figure 11. Polyphase wound rotor motors. The rotor has three-phase winding and connected with the suitable slip range and external secondary variable for resistance. The features of the motors are high starting torque with very low current and adjustable speed. Table 1, figure 12. Polyphase synchronized motors that employ the direct current rotor field alternating current and engineered state of starting torques are not normally high. These motors should be started under conditions no load, partial load, frequently used for power factor improvement. Table 1, figure 13. Alright, a shunt wounded motor, a series wounded motor, compound wounded motor, a split phase induction motor, central figure, starting capacity, starter induction, running capacitor, start and running. The starting capacity, running capacity, capacitor, starting capacitor, run, repulsion, starting induction, run, repulsion induction, repulsion motor, polyphase squirrel cage, polyphase wounded rotor, external resistance, polyphase synchronized motor, DC universal series. Chapter 2, controls, part 1, general.